Want future more updates? Just click subscribe button and bell button.
So let's start our discussion of this technology, IoT, which is stand for Internet of Things, by the vision shared by the inventor of this term, Mr. Kevin Ashton. So Mr. Kevin Ashton, a British technology enthusiast, he coined this term in the year 1999, and he envisioned IoT as the evolution of computer technology. And according to him, we can empower these computers, which are almost everywhere, which are almost ubiquitous, computers which have been helping us in managing our manufacturing processes, businesses, and day-to-day operations. Computers in the past few decades have helped us in automating most of the processes, and the field where computers were used is called computer-based automation. So computer in the last century helped us in automating most of the business and industrial processes, are now going to help us with this additional empowerment to take automation to next level. So by this empowerment of computers, Kevin Ashton meant taking automation to the next level, and he envisioned computers helping us build autonomous systems. So if you closely inspect the trend or the evolution of technology, this evolution of computer technology has resulted into introduction of many new computing paradigms, and we have several of them. Cloud computing, one of the subtopic of today's webinar, is one of the computing paradigm. We have several other computing paradigms being fueled by the emergence of Internet of Things. We have computing paradigms like edge computing, wherein we can run analytics at the edge of network. We have computing available in the form of fog computing, where we can have computing running in local data centers deployed within 10 to 15 kilometers range of our IoT deployment. Several other terms have been introduced, for example, embedded computing or device-based computing, where we can have analytics running on the devices themselves. But you might be knowing, because of certain constraints in terms of resources, it is challenging for us to have computations and analytics running on devices. So anyway, we are going to explore all these new and emerging computing paradigms, and I'll try my best to help you understand not only the difference between them, but will also help you building your IoT solutions. So IoT, once again, as envisioned by Kevin Ashton, is the evolution of computer systems, and essentially it is extension of computing and communication to mundane objects. So you can have a shoe with embedded computing and communication capabilities, transforming that mundane shoe into a smart shoe. You can have a washing machine with embedded computing and communication capabilities. In fact, you can have, let's say, all of your home appliances with embedded computing and communication capabilities, resulting into connectivity between them, and that connectivity resulting into creation of an intelligent environment called smart home. So this is the reason why when it comes to IoT, we call it extension of computing and communication to mundane objects. So next question is, why IoT? Or why IoT is such a highly promising technology? So at one side, IoT is helping us in the creation of new services, products, and business models. So see, we have hundreds of examples of services being offered to customers by companies to build better relations and to offer better experiences to end users or customers. New business models are being innovated, and in fact, IoT has made it possible for the businesses to offer their products in the form of services to customers. One of the best examples of a product being offered in the form of a service is online cab services, Ola and Uber. So this would not have been possible without technologies like IoT and cloud. IoT is opening all the avenues for the businesses to stay connected and keep their customers engaged. In the industrial domain, IoT has been helping industries in optimizing their resource consumption, resulting into enhanced productivity and increased operational efficiencies. IoT is also helping manufacturing industries to not only monitor the physical location of their assets, but also enabling and empowering them to monitor the health and performance of those assets deployed in remote areas. And as I pointed out earlier, IoT is helping us to build autonomous systems and environments. So we have new generation systems, new generation applications in the form of bots running on our mobile phones, running on our desktops when we browse internet, and are available to us in the form of standalone systems like Alexa in our homes. I would also like to share one more example of an autonomous system, and that too AI capable system, recently launched by Google and demonstrated by the CEO of Google, Mr. Sundar Pichai. This application is called Google Duplex, and this application is fully machine learning and AI capable and can make calls on your behalf to set your appointments with doctors or to book a table for a late evening dinner in a restaurant. We also have similar examples in the form of intelligent, smart physical environments. And here I would like to cite an example of Amazon Go technology. It is the best example of an autonomous retail environment. So Amazon Go, it's a technology which transforms a retail store into a smart retail store, enabling a customer to just enter, pick up a product, and walk out. Amazon is calling this technology just walkout technology. So we have hundreds and thousands of examples where IoT has been helping us not only save time and money, but also helping us deliver better customer experiences in the form of services and products. So now question is how to harness potential of this most promising technology, most fascinating technology of today's era. So when it comes to IoT adoption, we need to strategize our approach. There has to be a well-devised, well-defined adoption strategy. So there are few do's and don'ts when it comes to IoT adoption. And in fact, this adoption processes have been standardized, and we have these guidelines from standard development organizations. For example, we have Industry 4.0 standard from a group of manufacturers in Germany, and this initiative has been supported by government of Germany. Industry 4.0 is the best guideline for the manufacturing industry to embrace and adopt IoT in the right way, to help them gain maximum out of their IoT adoption. We have similar reference architectures and guidelines from other commercial and non-commercial initiatives. I'd also like to share an example of IIC, Industrial Internet Consortium. So IIC has published a reference architecture called IIRA, Industrial Internet Reference Architecture, and that is also a guideline for the organizations planning to adopt IoT. So what should be the best adoption strategy? That is the biggest question, and I have those do's and don'ts listed on my screen. So the first point is any organization or individual adopting IoT must embrace it as an enabler. IoT is one of those technologies which has recently disrupted not only businesses, but also the impact has been extended to our lives. So when it comes to IoT, people usually look at IoT as a disruptor. So here we need to change our perspective. We should look at IoT as an enabler, and it can really prove as an enabler when you align your IoT strategy with your business strategy. As an IoT adopter has to align IoT strategy with business strategy. Don't just look at IoT as a technology. Look at IoT as a technology which is going to be one of the component of your business strategy. Now when it comes to IoT, it's a fully data-centric technology, and we'll have more discussion on this. So the third point listed on my screen is follow your data. So to gain maximum out of your IoT strategy, the IoT strategy has to be data-driven. And we all know data is the most valuable asset of today's era. When it comes to IoT adoption, IoT alone is not going to help you gain maximum out of your data. There are few other technologies which have to be taken into consideration. For example, machine learning, AI, RPA, SDN. We have emerging telecom and communication technologies, and obviously data science. Now once you have decided to go for IoT, you will have to devise a data to business value mapping process, and we'll talk about this mapping process after a while. When it comes to IoT, you should always create better value proposition for your end users and customers, and should always focus on the integration of people, processes, and products. See, IoT is not just a technology which is going to help you build new products or services. As I alluded earlier, IoT has been helping you transform your processes to make them more efficient. And people is going to be one of the component, or one of the part of those processes. So you cannot ignore people component. So integration of these 3 P's, people, processes, and products, this has been highlighted even in Industry 4.0 guideline. Now when it comes to don'ts of IoT, as I alluded earlier, should not allow adoption of technologies like IoT, disrupting your existing processes. See, IoT is here to enhance the processes, not to disrupt them. So, you should try your best when it comes to building IoT products or creating IoT services or working on developing IoT projects. You should try your best not to disrupt existing processes, and don't employ rip and replace practices. So we have 2 types of deployment when it comes to IoT, 2 types of development strategies. We have greenfield development and brownfield development areas. Greenfield development refers to creation of a new product or service from scratch. So here you get all the freedom to choose your components, to choose your, let's say, SoCs and microcontrollers to build your smart products, to choose your data link layer technologies, for example, Bluetooth or Wi-Fi or Zigbee, to choose your web services architecture, for example, client-server architecture or publish-subscribe architecture, to select your cloud platform, and to select right tools, appropriate tools for enterprise integration. So greenfield development is not that challenging because you have all the freedom to choose all the components to build your and create your services and products from scratch. In contrast to this, brownfield development is more complex and highly challenging. So brownfield development refers to upgradation of existing products. For example, take example of a factory floor, a machine which has been there on the factory floor for last 20 years. Now, a factory owner may come to you as an IoT expert and may ask you to upgrade this existing system to enable it to connect to internet and to send all the data being generated by it to a cloud platform. Now this is the area which is going to be challenging for you, because most of the old generation legacy systems over there on factory floors are based on old generation PLCs, programmable logic controllers, and being driven and monitored by SCADA systems. SCADA stands for Supervisory Control and Data Acquisition Systems. Now since these machines, despite being old, are expensive, you cannot ask factory owner to replace these existing machines which have been running and which have been productive to be replaced by new machines, right? No one is going to go for it. So the idea here, brownfield development, talks about deployment of IoT endpoints in the form of retrofits on those existing machineries and products to capture, collect, and send data to cloud platform for higher level processes, and analytics, right? So we'll talk about this entire flow of data from, let's say, factory floor to cloud, and how those commands from cloud can be generated and routed back to those endpoints deployed on the industrial assets in one of my slides afterwards. Okay, last but not least, when it comes to IoT, an adopter should not forget to upskill or reskill their workforce. So here workforce comprises of not only the developers or project managers or IT guys. IoT is an operational level technology. So even those operators, machine operators, who are responsible for running this machineries on factory floors, they also need to be upskilled or reskilled to make this technology help its adopters in the best possible manner. Okay, so these are do's and don'ts of IoT adoption strategy. And now let us talk about the parameter or the factor which is at the heart of IoT adoption strategy. As I alluded earlier, IoT adoption strategy has to be data driven. And as we all know, most of the IoT projects, majority of IoT projects are leading to failure. And one of the primary reasons behind this IoT projects leading to failure is lack of a well-devised data strategy. So when it comes to building IoT products or IoT services, our focus must be on harnessing the hidden potential of data. Now here there are several implications. See, we live in an ocean of data. Our real life environments have data everywhere, but most of the time this data is hidden. If you look at your real life environments, objects in the real life environment and events have data associated with them. For example, if you look at your room has a set of attributes defining it physically as well as defining its internal environment. For example, height, width, and length of your room are its attributes, and these attributes have fixed values associated with them. Similarly, temperature, air pressure, humidity, light intensity, these are other set of attributes of your room, and these attributes do not have fixed values associated with them. These attributes have time variant values associated with them, and these values, fixed or time variant values, is our data. Similar to your room, your shirt or your shoe or your car or your door, or you talk about any mundane object. Every mundane object is a source of data. And being an IoT professional, we should look at each and every object around us as a source of data. Okay. Similarly, we also have data associated with events, right? So let's say an earthquake event will have data associated with it. And there are several events, and we can keep talking about all those events, natural events and man-made events happening around us, having data associated with them. So now question is, when we have so much of data, and this data, all the data which is there in the real life environment, is all this data going to be useful for us? Should we collect every bit and piece available in there in the real life environment? And the answer is no. When you collect data from the real life environments, and real life environments being naturally noisy and inconsistent, data you collect from them also contains noise and inconsistencies. And this noise and inconsistency may result in an inaccurate action. Right? So the right way of collecting data from the real life environment is making sure the data you are collecting is relevant. The data you are collecting has business values that you are looking for contained in it. Right? So data quality and quantity both are important. Quality, why? Because we have a principle called garbage in, garbage out. When you feed garbage into your processes, it's only garbage that comes out, right? So quality, yes, that has to be the first parameter we should look for when it comes to data. Second thing, the volume of data. We need to collect more data, and IoT has been offering you all those opportunities. Now, why do we need to collect more data? Because the business logics, and especially if your business logics are based on machine learning algorithms. So IoT is being powered by machine learning, right? When your business logics or the business applications are based on machine learning algorithms, keep one thing in mind, this machine learning algorithms, they perform better when you feed large amount of data into them. When you train them on large amount of data, the performance gets better. So this is the reason why we need to collect more data from the real life environment, and IoT has been helping us in doing that. Now once you have your data, what are you going to do with it? Okay, so the next step is we need to deploy right set of computations on them to convert them into appropriate action. Now what are those actions? Action may be creation of a new service. Action may be continuous delivery of an existing service. Action may be delivering a new experience to a customer. Action may be creation of a new product with new features. And action may be controlling of a real life environment. And there may be like more possibilities. So the question is this strategy has to be the central part of our IoT adoption strategy? And answer is yes. As I alluded earlier, IoT adoption strategy has to be driven by data. And this is the core mantra of success of any IoT project. Collect right set of data, deploy right computations to generate right and appropriate action. So data to action, this is the concept which is at the heart of IoT adoption. Now let us talk about those computations. As I just explained, your business logic, that is going to help you convert data into action. Is this process going to be automatic, or does this process involve human intervention? Okay. So that all depends on the kind of analytics you employ. So there are 4 types of analytics, data analytics employed by application developers and system builders. And data scientists are the experts who can help you selecting the right analytical approach for your project or for your development. The first and simplest type of analytics is called descriptive analytics. We also call it exploratory analytics. And descriptive analytics, as I said, it is simplest. It answers the questions like what happened. So here you can explore your data to find out what happened. But it requires or it involves a great degree of human intervention, human input, to convert those analytical outcomes into actions. Diagnostic is little advanced than descriptive. A diagnostic analytics answers the question like, why did something happen? Okay, and this is the type of analytics generally employed by doctors. So based on the symptoms of a disease, they tell what has actually happened, right? The next and the most commonly used, highly popular type of analytics is predictive. And predictive analytics is the most commonly used analytics in today's time, especially when it comes to IoT products building. Predictive analytics help your systems to be proactive, or your businesses and other processes to be proactive by predicting the future. So let's say, take example of a car. A car is an asset. So predictive analytics can help a service provider to predict future breakdown of the car. Similarly, in an industry, predictive analytics can help industries in predicting future breakdown of their production systems, helping them save lots of time and cost involved in keeping the systems running. Okay. So predictive analytics is being leveraged, and predictive analytics requires support of machine learning, deep learning, and AI technologies. Right. The next type of analytics, which is prescriptive analytics, it refers to 100% automation of your decision making process. So the conversion of data into action with zero human input or human intervention. This is what prescriptive analytics promises. But anyway, this is the most sophisticated form of analytics, and it's going to take some time to make this analytics available in the form of real services and products. So the analytical strategy of today's era is predictive analytics, and this is being leveraged by IoT developers and designers by deploying their computations on the data collected with the help of sensors to convert them into real life actions. I mean to say services, products, and experiences. Now once you have selected your computations, and once you have selected where are you going to deploy them, and we'll talk more about this deployment strategy on my next slide. So once you have your data with you, once you have your computations ready and deployed on them, and once you have your actions taking place, what is the most important part next to that? And the next part is gaining trust of end user. So no matter how good your products are, no matter how good your services are, if these products and services do not gain or do not earn trust of end users, your entire investment and your efforts will be in vain. Right? So the objective here has to be to gain or earn trust of your end user, and that can be done by ensuring security and privacy of the data. Okay. See, one of the recent survey revealed that privacy and security of the data and assets are topmost concerns of technology users. Right? So while building these systems, while choosing your components to acquire data, or while building your applications to deploy different types of computations and analytics on your data, while choosing the right channel to deliver actions, at every stage you will have to take security and privacy of data and assets into consideration. Now, once this is done, once you have your solutions ready, once you have your security and privacy countermeasures in place, the next step is deployment of this solution, right? See, here we're not just talking about a monolithic solution, a solution in the form of one piece. IoT is an example of distributed computing. Distributed computing, you will have applications, and these applications are going to run on different nodes in a network environment. So you'll have to, first thing, when it comes to deployment, you'll have to ensure connectivity and facilitation of seamless flow of data and messages. Exactly. And this is why technology infrastructure, the infrastructure you build to run these processes from data acquisition to action generation, technology infrastructure development is one of the most critical parameter of any IoT adoption strategy. Okay, so now what kind of technology infrastructure do we need? See, cloud is just one of the component of technology infrastructure. Okay, and why have we selected cloud to be discussed in this webinar? Because when it comes to IoT solutions, 60 to 70% of the solution is deployed on the cloud. I'm repeating it. Look at any large-scale IoT project. 60 to 70% of the deployment is on the cloud. Rest of the processes run on IoT endpoints and gateways. Okay, so let me help you understand this end-to-end processes and what are the best options available to us to have them deployed. Okay, so this is the kind of infrastructure required to build different types of IoT solutions. See, if you look at this picture, here I have taken an example of a problem domain. So a problem domain may be a smart home, a problem domain may be a smart factory floor. Now what are you going to find on this in this smart environments? You'll find IoT endpoints. Now what are these endpoints? These endpoints are IoT devices. These devices comprises of sensors, microcontrollers, communication interfaces, for example Bluetooth, Wi-Fi, Zigbee, LoRa, Sigfox. We have so many options. And the fourth thing, actuators which enable this endpoints to generate physical actions or influence physical environments. But generally we come across two types of IoT endpoints or IoT devices. There are endpoints which are used to acquire data from the real life environment. We call them sensor nodes, right? So here this blue color EP endpoint is our sensor node, and we can have multiple instances of the sensor nodes, right? We can have different types of sensors collecting data from the real life environment. Now once your sensor nodes collect data, what are you going to do it? So that is something that we will discuss. But let us look at this second type of endpoint here. So this endpoint at the other side is going to help us generate physical actions. It's going to help us control this real life environment or our problem domain. And the second type of endpoint is called control nodes. So endpoints or IoT devices help us either acquire data from the real life environment or help us control those real life environment by generating physical action. So I have a demo project running on my desk. I'm gonna demonstrate that to you at the end of session. I have built an endpoint, a sensor node, using a Node MCU IoT prototyping board. This Node MCU board, I'll show you this by sharing my webcam. Node MCU is a microcontroller board based on ESP12E Wi-Fi enabled microcontroller from ExpressIF. And I have connected a LM35 temperature sensor to it to collect temperature data from my room. Okay, so I'll demonstrate that project to you at the end of session. That is example of a sensor node. Okay, now reliable, right? So the next requirement, just keep in mind, the next requirement is obviously data storage facilities. Now once we have our data collected and stored, what are we going to do with it? So here comes the data processing or data science and all those practices offered by these fields, to deal with the data collected from real life environments. So the first process is going to be cleaning of your data. You will have to clean your data, you will have to filter your data, you will have to transform your data to select something that is going to be meaningful for you or useful for you. Okay, so this selection, cleaning, gleaning, filtering, transformation, all this group of processes is called pre-processing. Okay, so what does pre-processing do? Pre-processing convert data into information, meaningful collection of data, right? Transform data which is ready for the analytics I was talking about, right? Descriptive, diagnostic, predictive, and prescriptive. So to make your data ready for higher level analytics, pre-processing is this step. Now once you have your data ready for higher level analytics, then what you're going to do, you'll run this analytics to extract hidden knowledge. Now, and what is this knowledge? This knowledge is there inside your data, hidden in your data in the form of patterns, interrelations, and logics. Okay. So once you have extracted this knowledge from your data, which is collection of patterns, interrelations, and logics, what are you going to do? Either, now here comes the consumption part of the knowledge. Either you can present this knowledge to a human user to enable that human user to monitor this real life environment, or to enable that human user to make some decision and then send a control signal back to the environment converted into a physical action to monitor and control the real life environment. You will have to involve human users. But as I alluded earlier, this is not IoT. This is not IoT. See, IoT is enabling us to build autonomous systems. So what is the best thing we can do here at this end? What you can do, you can replace those human users consuming this knowledge by machine learning and AI capable applications. This machine learning and AI capable applications, they are capable of making decisions on the basis of knowledge presented to them. So what we do, what we humans do, this machine learning and AI capable applications can do it much faster and much better than us. Right? So once you have your machine learning and AI capable applications replacing human users at this end, your entire process, your entire loop is going to be fully automated. And this is what IoT is all about. IoT. So this applies to all the use cases. Let's talk about your driverless car, wherein like data collected from the car and from its surrounding, from the environment where this car is running on a highway. This data can be used by the computers embedded in that car to make all the decisions,
to take left turn or right turn to apply the brake, or to take car to a fuel station to refill the fuel, right? So you can see the approach that I've been discussing with you is the common approach, that could be adopted by IoT developers to build any type of IoT use case, from smart homes to smart cities to smart factories to smart appliances, everything. Now, next question is, okay, see, if you look at this entire process, data is being collected from here, action is being generated here. So where is our business logic? The business logic is everywhere. Business logic is here, which is going to help us selection the right attribute
to collect right set of data. Business logic is going to be here to convert this data into information, by selecting the meaningful data. Okay. Business logic is going to be here, which is going to help us identify right set of patterns and interrelations. Business logic is going to be here, which is going to make the right decision to control the real life environment in the right manner. And business logic is going to be here too, which is going to enable this endpoint to take the right action, right? So business logic is going to be everywhere, and this business logic, how is this going to exist at all those points? It is going to be there in the form of applications, software applications. So application running on a sensor node, application running over here, application running over here, applications running over here, applications running over here. So either you can have all these capabilities, from data acquisition to analytics to action generation, you can have all this capabilities or all this logic encoded in a single application, right? But just imagine how big that application is going to be, how complex that application is going to be, right? When you will code all your logic, from data acquisition to action generation in a single application. Just imagine how complex that application is going to be, and where are you going to run it? You'll require lots of resources to host and run this application. Lots of processing power, lots of storage memory, and I/O capabilities. So this is the reason, this is the reason why we need to break this entire logic into multiple pieces and have those pieces encoded in different applications running at different points. You can have, let's say, an application running on the sensor node, just helping you select right set of data from here. You can have an application running on this side, you can have application running over here, you can have applications running over here. Now next thing is, once you break your entire logic, once you into these pieces called applications, where are you going to deploy them? Okay, so here comes the deployment part, and here comes cloud computing into the picture. So this entire part from this end to this end, including the machine learning and AI capable application I was talking about, this entire part can be deployed on cloud. Can you get it? So just have your devices or IoT endpoints deployed in the real life environment, and you can have this IoT endpoints connected to cloud over the internet. This is IoT. So why do we need to connect this IoT endpoints into internet? Because that is the only way to access cloud. What is cloud? Cloud, and we'll talk more about this, cloud is internet-based computing infrastructure. Okay, so let us look at the cloud now. What is a cloud and why cloud? Okay, since like as I pointed out earlier, most of our computations of an IoT solution, and as I pointed out, that makes around 60 to 70%, right? So 60 to 70% computations are going to run on cloud, right? And this was anticipated by Gartner, and they published a report in 2017, and they predicted that the data center of gravity is rapidly shifting towards the cloud. Organizations prefer to have their data stored, processed, analyzed, and consumed on cloud. Okay, so the cloud is gonna help you by offering services like data collection, processing, storage, visualization, and analysis. Okay, so let us look at the basics of cloud computing. I'm just going to help you understand what is a cloud, and then we'll explore two of the leading cloud platform, AWS and Azure. So a cloud is basically an internet-based computing infrastructure. It's a metaphor that refers to a cluster of data centers is spread across the globe, connected over the internet. Right? So you can call it a cluster of internet connected physical data centers. And what is there inside these data centers? They have physical resources in the form of servers, storage solutions, and networking equipments. And this cloud, this entire physical infrastructure is accessible, which can be easily configured to deploy your solutions through web portals. So we have web portals, for example, AWS. If you visit AWS website, the web portal will allow you to create virtual machines over here. The web portal will allow you to deploy your applications over there, right? I will help you understand that, and since the web portal is the interface to this cloud platform, internet is the only medium to gain access to them. Okay, so I'll quickly walk you through this different types of deployment models, cloud deployment models, and service model employed by cloud service providers. So we have 4 types of cloud infrastructure or deployment models. A public cloud platform is open for all, and the best example of a public cloud platform is AWS and Azure. A private cloud platform, generally owned by a single organization, and most of the time banks, defense organizations, and in the industries go for private infrastructures. A community cloud platform is owned by a group of organizations, and a hybrid kind of model is new in this group, and most of the IoT projects, most of the IoT deployment use hybrid deployment model. Hybrid deployment model means a combination of 1 or 2 or more of this models. Now let us look at service models, and I don't think so this is going to be new for you guys. Infrastructure as a service refers to infrastructure provided by service provider, and that comprises of only server, storage, and networking solutions. PaaS, platform as a service model, refers to availability of full-fledged, fully configured environment for the deployment of your applications. So let's say when it comes to deployment of websites, we go for PaaS model. PaaS stands for platform as a service, means you have your hardware infrastructure ready, and you have your runtime environment, operating system, middleware, databases ready to host your applications. And you have SaaS model, which is the most popular cloud computing service model, and one of the major contributor in the evolution of cloud computing industry. SaaS stands for software as a service. Means a cloud will have everything on it, your applications available over there. So that, for example, AWS has more than 4,000 services, fully configured services. The services are integratable services. So what you can do, you can create a larger applications by connecting these building blocks to each other. Okay, so SaaS is one of the most popular service model in today's time, and most of the IoT solutions are actually based on SaaS model. Let me show you an example of an IoT solution. I have this over here at the end of my presentation, but let me help you look at this. See, this is an end-to-end IoT application architected on AWS platform. So AWS is the world's leading cloud platform, and AWS offer high-end IoT services. Okay, so AWS allows you to connect your things to one of the front-end service called IoT Gateway. IoT Gateway also hosts MQTT broker, and that MQTT broker allows your devices to connect to it and then enable them to exchange messages with each other. Okay, so IoT Gateway is the front-end service on AWS cloud, and then you have a service called IoT Rule Action. So what you can do over here, you can define rules to select and push your messages to databases. So one of the best type of database available for the storage of IoT messages and IoT data is this non-relational database on AWS called Amazon DynamoDB. Amazon DynamoDB is a non-relational NoSQL database and suitable for the storage of unstructured data. So most of the time data coming from IoT devices are unstructured data, right? And then you can have your own code deployed on AWS in the form of AWS Lambda functions, and you can have this entire data flowing into your database computed and then displayed to your end users in the form of a beautiful real-time dashboard with the help of AWS IoT Gateway. So these are these kind of services I was talking about. These are building blocks. These are readily available over there. So you don't need to create a process to ingest your data. IoT Gateway is already there. You do not need to create a logic. You don't need to write code to help you select your data by running basic analytics on them. IoT rule action is there. You don't need to deploy a database solution to have your data stored. Amazon DynamoDB is already there, right? You don't need to create a virtual machine to have your solution running. A service like AWS Lambda, which is serverless computing engine, would allow you to have your code hosted on AWS. Right? So these are the building blocks, and this is the beauty of SaaS model, software as a service model. Software as a service model allows you to connect these building blocks to each other to build end-to-end solution. The example is here on my screen, right? So what I've done, I have created this use case physically on my desk. As I said, I'm going to share my webcam to show you a sensor node collecting data from a temperature sensor and then pushing this data to cloud. Okay, so let us go back to our discussion. So I just talked about this. Yes, these are the deployment models, and this is the IoT, an example of an IoT ecosystem where you will have your devices connected to cloud, and then finally integrated cloud on the other side, integrated and connected to your enterprise applications or user applications running on user devices, for example mobile phones. Okay, so this part, here we face challenges like connectivity and addressing scale of devices which are getting connected to cloud. And when it comes to IoT, we just don't talk about 1 or 10 or 15 devices. We talk about millions and billions devices, right? So this connectivity and device management is one of the challenge that is going to be faced by you at this side, and enterprise integration or IT and OT integration is the second challenge you will face here on the other side of the cloud. Risk can easily be managed by the cloud. So once you have connectivity challenges, once you have overcome connectivity challenges, once you have overcome IT and OT integration or enterprise integration issues, then rest is gonna be smooth for you. Okay, so let me help you understand what kind of capabilities you should look for when it comes to selection of an IoT cloud platform. What kind of services have to be there to allow you not only connect your devices to facilitate seamless exchange of data and messages, but also allow you to have your data stored for processing and analytics. So the first step is, as you can see here in this picture from IoT Analytics website, connectivity is the bottommost layer, device connectivity. So cloud platform, IoT cloud platform offers support for standard application layer protocols. And one of the most popular application layer protocol in IoT domain is MQTT, right? Message queuing telemetry transport, MQTT, which has been derived from AMQP. AMQP stands for Advanced Message Queuing Protocol. Now MQTT is the simplest, lightweight, code and bandwidth efficient protocol. It is the most popular and most suitable protocol for IoT communication. But at the same time, you cannot ignore HTTP. HTTP has been there for so many years, and HTTP is the preferred application layer protocol or language of web applications on the internet. Right? Client server architecture is generally built on HTTP protocol, and the MQTT protocol allows you to build IoT network based on publish subscribe architecture. That is considered to be better than client server architecture and more suitable for IoT communication, right? So when it comes to device connectivity, you will have to choose your data link layer technology, Bluetooth, Wi-Fi, Zigbee, LoRa, Sigfox, and we have so many innovation in that space. I covered this in one of my previous webinar. We have Bluetooth 5, we have Wi-Fi Holo, we have Zigbee 3.0 standard, right? So device connectivity at data link layer and application layer, you have protocols like HTTP, AMQP, MQTT, and CoAP. CoAP stands for Constraint Application Layer Protocol. It is still at a research level. So MQTT, AMQP, and HTTP, these protocols have to be supported by the cloud platform of your choice, right? The next service that you should look for is device management. Okay, device management means assigning identities to your devices and keeping track of them. Device management also allow bulk provisioning and configuration of your devices. Device management also allows monitoring and tracking of the device and keeping track of software updates and patching process. Right? So your cloud must offer device management services to you. Now when it comes to storage, IoT data demands specialized storage services. Right? So we have highly efficient services, for example, S3 bucket service on AWS, the best example of object storage. Right? Similarly, databases, when it comes to databases, non-relational databases are considered to be better than relational databases for IoT data storage. Okay, so we have MongoDB. In that area, we have DynamoDB, and we have Cosmos DB on Azure. Okay, these are databases, non-relational databases for IoT data storage on cloud platforms. Visualization, yes. So when it comes to visualization, let me share an example of a visualization service, analytics and visualization service, especially created on Microsoft Azure for IoT data, and this series is called TSI, Time Series Insight. Okay. I hope my screen is visible to all of you. Right, this is the Time Series Insight, Time Series TSI. Microsoft calls it, or Azure calls it TSI, Time Series Insights. And Time Series Insight, it's a highly efficient and real-time visualization and analytics service. You can have your data. For example, here I have last 6 minutes data being collected and plotted over here from a factory. So it's a demo of Time Series Insight. So TSI, because IoT data most of times come from devices in the form of time series, so you need specialized services for time series analysis. Okay, so TSI is the best example of a time series analytical and visualization service from Microsoft Azure. Okay, you can explore TSI later. Okay, now when it comes to enterprise integration, and yes, so So cloud platform do offer lots of services for enterprise integration, and one of the protocol I would like to talk about here, I just mentioned it. This protocol is called OPC UA, which allows older and legacy systems to be integrated with IoT deployment. OPC UA is the protocol. We should also look for edge computing solutions, because edge computing means running your storing a data and running analytics at the edge of network, right? So cloud platforms, for example AWS and Azure, both of them are offering highly specialized services. We have a service called AWS Greengrass, right? AWS Greengrass from AWS platform, and Azure IoT Edge SDK. Right? These are the services offered by this leading cloud platform service providers to have your data collected, stored, processed, and to stay in sync with cloud deployment. And all these facilities are going to be available at the edge itself. So you can explore Amazon Greengrass, you can explore Azure IoT Edge service. These are the kind of services offered in the form of software solutions by this leading cloud platform vendors. Now, when it comes to device and network security and platform security management, obviously these are going to be joint responsibilities of the cloud platform vendor and you as a solution developer. So yes, cloud platforms, they do offer this services to ensure not only the security of their platform, they are also now offering extended security services to ensure security of end-to-end IoT solutions, from device to network to cloud to backend applications. Okay, so these are the kind of capabilities you should look for when it comes to selecting an IoT cloud platform. Now let me share examples of two leading cloud platforms. Okay, so we have IoT services available from AWS, and we have IoT services available from Microsoft Azure. See, AWS offer you services. So as I just pointed out, edge computing services. These are called extended services. So AWS Greengrass is the solution I was talking about. Amazon FreeRTOS, a real-time operating system for microcontrollers. SDKs for application development to run on your endpoints. And so this is a group of services offered by AWS to help you deploy computations at the edge of network, on a gateway, or on your devices. The cloud part of AWS has this group of services. The front end service is a message broker, a rule engine, authentication and the authorization service, so that generates certificates for device identification, and a device shadow, a twin, a virtual twin of your physical device. Okay, so these are the group of services, and Azure on AWS we call it AWS IoT Core. We have device management services, enabling you to update software of your devices remotely. So we have OTA and FOTA facilities available over here. OTA stands for over the air update. FOTA stands for firmware over the air upgrade. Similarly, there are services to enable deployment of your devices in bulk, provisioning them, and configuring them to work with the cloud platform. We have AWS IoT Device Defender services, the kind of security services which ensure end-to-end security, and we have AWS IoT Analytics services, especially created for IoT data analytics. Right, so these are the group of services available on AWS Cloud, and then we have group of services which are called backend services, and these backend services, the services can be used for enterprise integration and like passing your data collected from here to enterprise applications. So we have storage services over here, Amazon S3. We have machine learning services, Amazon SageMaker, and we have AWS Lambda. We have visualization service, Amazon QuickSight, and lots of other services. Okay, so as I said, AWS is the world's leading cloud platform. And let me take you to AWS IoT console. So I'm not taking you. So here too, see, I have logged in into my AWS account, and this is the page called AWS IoT console. On AWS IoT console, you can select your services. For example, IoT core services I was talking about, and other services like compute, storage, and database and management services. Okay. When you go to IoT console, here it offers you to register and manage your devices. If I go to manage section, here these are the devices created by me, and every device will have a type, and for security, every device will have a certificate and policy attached to it. Okay. Greengrass I was talking about. So from here you can download the Greengrass core, Greengrass SDK, and the runtime environment which is going to run on your edge gateway. And this AWS IoT also allows you to create a dummy subscriber, MQTT client, to connect to one of the topic, to subscribe to almost all the topics, with a wildcard called hash. So hash in MQTT protocol, we use this wildcard hash to subscribe to all the topics that may exist on a broker. Okay, so I just created a dummy client here, and I have subscribed to this topic, one topic over here. Now let me check whether I have my okay, so I think I will have to restart my Raspberry Pi. No problems. So once my Raspberry Pi starts, I'll show you how to push data from an MQTT application. Like this is the application I'm going to demonstrate to you after a while. Okay, so this is the AWS IoT group of services, and we are just exploring IoT core. IoT core comprises of a MQTT broker, and that broker can collect data from the applications running on endpoints. Okay, so I'll get back to you this. Let us look at the services being offered by Azure. Okay, the Azure holds second position when it comes to cloud computing. Azure holds second position, but Azure has been at a position now where it is being considered the leading competitor of AWS platform. Azure offers the services for device connectivity and management. Azure offers services for application and business logic development. Azure Function is analogous service to AWS Lambda. Azure offers relational and non-relational databases. For example, I talked about Cosmos DB. We have blob storage which is analogous service to S3. So most of the services on Azure are analogous to services available on AWS. So let's say if someone who has been working on AWS, he or she can easily become an expert of Azure, because most of the services are analogous to each other. Okay, for example, this table of blob storage is analogous to S3, Cosmos DB is analogous to DynamoDB, and so on. Azure also enables you to deal with big data. So when you have data coming to you in the form of big data, a large volume of data, Azure offers you handle this big data efficiently by leveraging the Hadoop ecosystem components and services like HD Insight, Data Factory, and other. Azure offers you two types of approaches: cold path analytics and hot path analytics. So cold path analytics means having your data flowing in, and then you store them, and you store them for long-term analysis. Okay, so once you store your data, it becomes cold, right? And then you run different types of analytics on it to extract trends and patterns hidden in. This is called cold path analytics. So this is where like machine learning and HD insights, Hadoop insights kind of services play their role. When it comes to hot path analytics, this is where a service called stream analytics comes into picture. Stream analytics enables you to run analytics on your data in runtime. So let me take you to Azure portal. So let me check whether I have this portal open. Okay, I will have to open it. So I do have a stream analytics job created over there. So this is stream analytics jobs. What they do, they take data coming from your endpoints, and then you run your analytics on it, and this analytics can easily be created using simple SQL statements. Okay, so I have a stream analytics job over here. This is Azure's IoT dashboard, and the front end service for device connectivity on Azure is called IoT Hub. You can create a IoT Hub, and inside the IoT Hub you can create your devices, you can manage your devices, you can manage device interaction, let's say cloud to device flow and device to cloud flow, both. So this is what IoT Hub is. I was talking about this stream analytics job. I have stream analytics job created over here. Okay, and this, as you can see here, it's gonna be in a stream input and a stream output. So in your job, you will have to define from where your data is coming. So your data may come from IoT Hub, right? So here I configured my
IoT Hub is input stream, okay, and then outputs. In outputs, you can define an endpoint. An endpoint. For example, you can have your data forwarded to blog. You can have your data forwarded to other services. So here I forwarded my data to service bus queue. And what was the selection criteria? The analytics. Okay, let me get back to that page. Okay, so the logic I defined over there is simple. I selected all the data coming to IoT Hub, and then I selected the temperature values. So I was sending data to IoT Hub containing temperature values. So I selected only those observations or data points where temperature value was greater than 28, right? And then what I did here, I created an email service to send an email alert to me. So the solution that I created over here, but anyway, because we are running short of time, I won't be able to demonstrate the entire solution on Azure.
So this is what Azure offers you, right? Azure offers you different types of solutions for stream analytics, hot path analytics. So stream analytics is a service that enables hot path analytics of your data coming to Azure, right? Okay. So with this, I covered all the topics that I was supposed to cover in this webinar. Being here, thank you very much for taking your time to attend.